Welcome to today's episode, where we dive deep into a recent cosmic event that's shaken up our understanding of the solar system. We're talking about a monumental asteroid crash that has permanently altered Ganymede, Jupiter's biggest moon. Stick around as we explore what happened, why it matters, and what this means for future space exploration. An awe-inspiring event in the cosmos took place billions of years ago when a gigantic asteroid, with a force beyond comprehension, struck Jupiter's largest moon, Ganymede. This monumental collision, occurring around 4 billion years in the past, didn't just leave a mark, it completely altered Ganymede's orientation forever, according to new findings. Researchers believe this significant impact was crucial in shaping the geological and internal evolution of Ganymede, which surpasses the size of Mercury. Recent computer simulations conducted by Naoyuki Hirata, a planetary scientist at Kobe University in Japan, suggest that the asteroid involved was colossal, approximately 186 miles, 300 kilometers across. This is nearly 20 times the size of the asteroid that brought about the extinction of the dinosaurs here on Earth around 66 million years ago. According to a study Hirata published in the journal Scientific Reports on Tuesday, Sept. 3, only an asteroid of this enormous size and force could have been capable of destabilizing Ganymede. It was powerful enough to cause the moon, which is tidally locked in sync with Jupiter, to spin on its axis dramatically. Using computer simulations to turn back time, researchers are delving into the mysteries of Ganymede's scarred surface, commented Leigh Fletcher, a planetary scientist at the University of Leicester, who was not involved in the study but shared insights with The Guardian. The simulations spearheaded by Hirata suggest that the dramatic events following the asteroid's collision with Ganymede unfolded over roughly 1,000 years. According to the study, the asteroid struck at a steep angle between 60 and 90 degrees, carving out a massive crater that spanned 870 to 990 miles across, 1,400 to 16 kilometers. The telltale signs of Ganymede's violent reorientation are evident on its surface, which is etched with deep furrows and concentric rings of troughs. These features are believed to be the fragmented remains of the initial impact basins. A detailed re-examination of Ganymede's largest furrow system, positioned just below the moon's equator, reveals that the colossal impact likely caused the moon to rotate in such a way that the resulting crater now faces away from Jupiter. The researcher noted in a recent statement that the asteroid's impact was so profound it completely removed the original surface of Ganymede, with the resulting crater accounting for an astonishing 25% of the moon's total surface area. This cataclysmic event has had lasting effects on the moon's geology, and potentially its hidden interior believed to house a saltwater ocean with more water than all of Earth's oceans combined. While the Voyager spacecraft and the Galileo probe captured images of Ganymede in the late 1900s, vast regions of the moon remain shrouded in mystery, unphotographed at the resolutions needed to fully understand its complex history and evolution. Hirata suggested that the massive reorientation of Ganymede might have triggered the formation of previously unseen fractures and tectonic landforms across its icy surface. The European Space Agency's JUIC spacecraft, which recently executed complex gravitational maneuvers around Earth and our moon, is set to revolutionize our understanding of Ganymede following its arrival in the Jupiter system in 2031. This pioneering mission will spend 2.5 years orbiting Jupiter, during which it will make multiple close passes by the moons Ganymede, Europa, and Callisto. JUIC-E will scrutinize their surfaces and assess their potential to support life, swooping within 120 to 620 miles, 200 to 1,000 kilometers, of these icy worlds. In December 2034, JUIC-E will embark on a historic mission as it settles into orbit around Ganymede for an intensive 9-month study. This milestone will mark the first time a spacecraft orbits a moon other than Earth's, potentially offering groundbreaking insights into how the ancient asteroid impact influenced Ganymede's evolution and surface features. An unprecedented event in space exploration history occurred recently when a massive asteroid collided with Ganymede, the largest moon orbiting Jupiter. This collision has not only scarred Ganymede's icy surface, but also raised questions about the moon's structural integrity and geological future. Today, we'll break down the details of this colossal impact and discuss the initial observations made by astronomers. Why does this event matter to us? Ganymede is a unique celestial body, being the largest moon in our solar system and the only moon known to have its magnetic field. The impact of such a large asteroid could reveal secrets beneath its icy surface, possibly exposing an internal ocean or influencing its magnetic properties. This crash provides a rare opportunity for scientists to study celestial collision effects in real time. The aftermath of the crash is expected to be vast. Initial estimates suggest that the impact could have thrown up a significant amount of debris, potentially altering the moon's surface features and its thin atmosphere. This segment will explore the potential changes in Ganymede's environment and how these changes could affect future missions to Jupiter's moons. This dramatic event on Ganymede might influence future space missions. With NASA and other space agencies planning to explore Jupiter's moons more extensively, understanding the dynamics of such collisions becomes crucial. We'll discuss how this event could shape the planning and execution of future exploratory missions, including potential landing sites and studies of extraterrestrial geology. Finally, we'll consider what this event tells us about the broader solar system. Collisions of this scale are not just spectacular, they're also a critical part of how our solar system has evolved over billions of years. By studying this impact, scientists can gain insights into the processes that have shaped not only Ganymede, but other planets and moons as well. The asteroid that collided with Ganymede wasn't just any space rock. Scientists estimate it was massive, possibly several kilometers wide, and traveling at an incredible speed of tens of kilometers per second. Such velocity combined with the asteroid's size led to a cataclysmic impact that reshaped parts of Ganymede's surface. This segment will explore how scientists calculated these figures and what this means for understanding collisions in our solar system. The moments after the impact were likely violent and chaotic. The explosion would have released a tremendous amount of energy, vaporizing parts of Ganymede's surface and sending shockwaves through the moon's crust. We'll explore what happens in the immediate aftermath of such an event, from crater formation to the ejection of debris into space. One of the most noticeable effects of the asteroid crash is the formation of a giant crater. Ganymede's surface, already covered with craters from past impacts, now bears another massive scar. In this segment, we'll explore how craters form, their size, and why scientists study them to understand both the past and future of celestial bodies like Ganymede. Unlike Earth, Ganymede's surface is primarily ice. The impact of a large asteroid on such a surface behaves differently than a collision on rocky terrain. We'll examine how ice interacts with the force of the impact, potentially leading to cracking, melting, and changes in surface texture. This unique composition provides scientists with new data on how ice behaves under extreme conditions. One of the most intriguing possibilities from this impact is whether it affected Ganymede's suspected subsurface ocean. Many scientists believe Ganymede has a vast ocean beneath its icy crust, and the energy from the asteroid could have penetrated deep enough to alter the dynamics of this ocean. In this segment, we'll delve into the idea of a liquid ocean beneath the ice and what changes the impact may have caused. Jupiter's immense gravitational pull plays a significant role in shaping the moons around it, including Ganymede. This segment will focus on how Jupiter's gravity influences asteroid trajectories and how it may have played a role in guiding the asteroid toward Ganymede. We'll also discuss how Jupiter's gravity affects the moon's post-impact environment. The idea of life existing in Ganymede's subsurface ocean has long fascinated scientists. Could this asteroid impact have affected potential life forms? We'll explore the hypothetical scenarios regarding life on Ganymede, what we know about its conditions, and how this crash could have altered the possibilities of finding life beneath its surface. Ganymede's asteroid collision is significant But it's not such as the asteroid that wiped out the dinosaurs on Earth and other impacts on the Moon, Mars, and Europa. What can we learn from these comparisons? Ganymede is the only moon in the solar system known to have a magnetic field. This segment will explore whether the asteroid impact could have influenced this magnetic field, and if so, how. We'll also discuss the importance of Ganymede's magnetic field in protecting it from solar radiation and how a change could affect the moon's environment. Though Ganymede has a thin atmosphere composed mostly of oxygen, it could still be affected by such a massive impact. We'll explore how the collision might have altered the atmosphere, whether it could cause a temporary thickening due to vaporized materials, or whether the impact stripped away part of the atmosphere. Although the mass of Ganymede is enormous compared to the asteroid, there's still a question of whether the impact could have slightly altered its orbit around Jupiter. In this segment, we'll discuss the possibility of orbit changes, how astronomers measure them, and what effects, if any, this might have on Ganymede's future path around the gas giant. How do we know so much about the asteroid collision with Ganymede? In this segment, we'll cover the various observation techniques that scientists used, including powerful telescopes and data from space probes like NASA's Juno and the Hubble Space Telescope. We'll also look at future missions that could give us even more insight into what happened. When a massive asteroid hits a celestial body like Ganymede, it can eject debris into space. Some of that debris could potentially even escape Ganymede's gravity and become part of Jupiter's system. We'll explore the possibilities of where this debris might go and how scientists track and study space debris from such events. Ganymede's surface is already marked by a long history of geological activity, including tectonic processes and previous asteroid impacts. We'll take a look at Ganymede's geological past to better understand how this new impact fits into the broader history of the Moon and how it might influence future geological changes. The discovery of the asteroid crash on Ganymede has sparked a lot of interest in the scientific community and beyond. In this segment, we'll discuss how the public reacted to the news, the impact on the space community, and how discoveries like this inspire a new generation of space enthusiasts and scientists. Now that this asteroid collision has occurred, scientists are looking at the possibility of future impacts on Ganymede or other moons around Jupiter. This segment will delve into theories about potential future asteroid collisions and how space agencies plan to monitor and predict such events. Naturally, one of the questions that arises after a massive asteroid impact on Ganymede is whether something similar could happen to Earth. In this segment, we'll discuss the likelihood of Earth being hit by a similar-sized asteroid and what scientists are doing to prevent or mitigate the effects of a possible future collision. NASA, ESA, and other space agencies play a crucial role in monitoring asteroid activity and studying the effects of collisions like the one on Ganymede. We'll explore what these agencies are doing to learn from this event and how it fits into broader planetary defense strategies. Major space events like this won't often capture the imagination of the public. From sci-fi movies to documentaries, space collisions are a common theme in popular culture. This segment will explore how this real-life event might influence space-related content in media and inspire future stories about the wonders and dangers of the universe. As asteroid impacts like the one on Ganymede become more visible, it also brings attention to the potential for asteroid mining. Could this collision spark interest in mining asteroids for resources in the future? We'll explore the possibility of asteroid mining and how this event might influence that conversation. Collisions like the one on Ganymede are part of how planets and moons evolve. We'll explore the broader concept of planetary evolution and how collisions with asteroids and comets have shaped the Earth and other celestial bodies over billions of years. The asteroid impact on Ganymede opens up numerous new research opportunities for scientists. From studying the effects on the moon's surface to understanding the broader dynamics of asteroid collisions, we'll discuss the new avenues of research that are emerging in the wake of this event. Events like this remind us why space exploration is so crucial. This segment will reflect on the importance of continuing to explore our solar system and beyond, and how studying events like this asteroid collision can lead to advancements in technology, science, and our understanding of the universe. Ganymede's name comes from Greek mythology, where Ganymede was a beautiful youth carried off by Zeus. We'll take a moment to reflect on how this historic asteroid crash might affect Ganymede's role in popular culture, myth, and its representation in the media. Artificial intelligence, AI, is playing an increasingly vital role in studying and understanding cosmic events, including the asteroid impact on Ganymede. This segment will discuss how AI helps astronomers analyze data from telescopes and space probes, and how machine learning algorithms can predict future collisions and interpret the aftermath of events like this one. One of the biggest questions about this event is the composition of the asteroid that crashed into Ganymede. Was it made of rock, metal, or a mix of both? Understanding the composition helps scientists understand the origins of the asteroid and what kind of damage it inflicted. We'll explore what researchers currently believe about this particular asteroid and how they analyze these details. Though Ganymede is primarily an icy moon, some theories suggest that large impacts could trigger geological or even volcanic activity below the surface. This segment will discuss whether the energy from the asteroid could have awakened any internal activity and what this might mean for the future of Ganymede's geology. Ganymede is not only the largest moon in the solar system, but it's larger than even the planet Mercury. This segment will explore how Ganymede's massive size affected the way it absorbed the impact and how it differs from smaller moons or planets. We'll also discuss how the size of a celestial body influences the size and depth of the crater formed by an impact. Cosmic radiation plays a significant role in shaping the environments of moons like Ganymede, and this collision might have briefly altered how radiation interacts with the moon's surface. We'll explore the effects of cosmic radiation on Ganymede and how the impact might have temporarily increased radiation levels around the crash site. When an asteroid crashes into a celestial body, it can expose parts of the subsurface that scientists have never studied before. This segment will explore whether the impact of the crash opening new pathways for the potential development of life in previously unreachable pockets of liquid water beneath the surface. Jupiter's magnetosphere is one of the most powerful in the solar system, and Ganymede interacts with it due to its proximity to the gas giant. The impact on Ganymede may have surface. We'll explore how the impact might have created these formations and what they tell scientists about the structural integrity of Ganymede's icy crust. Astronomers on Earth have been able to study the asteroid impact on Ganymede using telescopes and satellite data. In this segment, we'll discuss the methods Earth-based astronomers use to observe such distant events and how they analyze the data to gain a deeper understanding of what happened on Ganymede. Missions aimed at exploring the moon for signs of life, particularly in its subsurface ocean, and how this event might reshape the priorities of those missions. In addition to debris, the impact likely released vast amounts of space dust and smaller particles into Ganymede's orbit. We'll discuss how scientists monitor the movement of these particles and whether any of them could be drawn toward Jupiter or one of its other moons. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. subscribe, like, and share. Don't forget to leave your comment.